2020 has been a momentous year for science and global health.
It sounds like a mind-bending problem.
Increased understanding and awareness of the interconnections between humans and planet Earth has never been more pertinent.
It feels magical here.
And Irish research is helping drive us towards a brighter, better world.
It's ingenious technology.
This week on 10 Things to Know About, we're looking at water in Ireland. Too much of it and too little. Kathriona meets the researchers unlocking the mysteries of Ireland's Vanishing Lakes. Aoibhinn reveals how our past may provide clues to help us manage future climates. But first, I find out why the rain that falls from the sky is only half the problem. Over millennia, immense geological change has formed and shaped Ireland's spectacular landscape of mountains, rivers and lakes. But groundwater, where water lies hidden within the soil and rocks underground, is no less important, providing a source of drinking water and connecting into our watercourses and ecosystems. Seasonal changes in rainfall can form turloughs or vanishing lakes. And while they can be really important for biodiversity, they can also be associated with devastating flooding events. Monica Lee is head of Groundwater with Geological Survey Ireland. Monica, when we think of flooding, the first thing that might come to mind are those dramatic news reports and devastating scenes across the country. But there's actually two types of flooding, aren't there?
Yes, there's surface water flooding and there's groundwater flooding, and we're really more interested in the groundwater flooding. So groundwater flooding is essentially where the rainfall amounts are greater than the capacity or the storage in the ground itself. So you can imagine that all of the cracks in the rock and all of the pores in the soil fill up, and after longer periods of rainfall, this actually seeps out onto the surface. So this is called groundwater flooding.
And then surface flooding is slightly different.
Yeah, so surface water flooding is really where you might expect it to be there for a few hours or a few days if it's particularly bad. With groundwater flooding, we're talking about weeks or months.
There are hundreds of so-called vanishing lakes around Ireland, turloughs. Can you tell me about them?
They're essentially seasonal lakes. They fill up very gradually in the winter, and then they empty very slowly during the spring and summer when the rain generally recedes. So in Ireland, we actually have over 500 of these features, and even we have townlands that are called Turlock or Turlock Moor. And because of the regularity of the filling and emptying, they actually develop very rare kind of flora and fauna. So many of these turloughs are actually protected habitats as well.
In Ireland, groundwater flooding occurs mainly in the turloughs and lowlands to the west of the Shannon. The flooding is fundamentally linked to the limestone bedrock of the area and specific rock formations known as karst.
We have this generally flat, low-lying area, and that's all underlain by limestone. And there are different types of limestone, but the purer the limestone, the less clay content that's in the limestone, the more likely they are to be karstified. And karstified is really where rainwater can dissolve the limestone because it's slightly acidic. So we find that in karst rocks, where we have all of these little cracks in the rock, they can become very slowly dissolved out over tens to hundreds of thousands of years. And that can actually increase the groundwater flow and groundwater capacity that can move through those rocks.
About half of Ireland is underlain by limestone, and high levels of rainfall into groundwater saturated areas pose a significant flood risk to local communities.
What we've been doing over the last few years is to collect more data, put monitoring networks into these turlock areas, and also then to develop new models so we can actually produce predictive maps for groundwater flooding. So we'll be able to plan where to have infrastructure, where to have houses, the areas to avoid where to have all these things as well.
As flooding events become more frequent and extreme, we need to better understand how water moves through these interconnected areas underground. I'm meeting Ted McCormack in Cool Lake, one of the largest turloughs in the country.
Cool Turlock is really the central point of the Gort Lowlands catchment. Three rivers come off the Slievachty Mountains to the east, and they flow underground and underground again until they resurface just to the north of the Turlock here. At peak rate, it can fill at approximately 25 Olympic swimming pools per hour.
Wow, that is some amount of water. And is it because of the geography of the area that we have these problems with flooding?
Turloughs happen in low-lying topographic basins, so they're not very far from the water table, really. So it doesn't take an awful lot for the water to come out and onto the surface.
Anyone who lives near a turlock will be familiar with Ireland's vanishing rivers and lakes. But any mystical fascination is lost when you've been flooded year after year. David Murray lives in South County Galway. I have never seen a river appear out of the ground before.
This is about the 5th time now that this river has appeared out of the ground. The deciders of what the flooding levels are the turloughs. So what happens is the more water that pours into Cool Lake, the higher Cool Lake level rises, and the swallow holes from the different rivers stop working because there's no pressure, and it just backs up and the whole system breaks down then.
In an extreme flood event, what level does this river get to?
This could rise 30, 40 foot. That would be up to the tree line around us here.
Wow, that is unbelievable.
First thing that happens is typically septic tanks start flooding. The second is roads start closing, and once those start closing, the whole community becomes paralysed. In the 2009 flood event, if I wanted to get my children from the house to the school, which is normally about 500 metres, it was actually a 40-mile round trip. The water can stay, and some of the roads have been closed down for 5 months.
So what can be done?
The kind of conclusions that we've thought of as a community is we need to stop the turloughs reaching a critical level, and then we have to find a way to keep those. That's where the science comes in.
Tackling groundwater flooding is a sizable and complex challenge, but for the affected communities, it's an absolute priority to protect their homes, livelihoods and way of life. Do we have any history of flood relief works around turloughs?
Yeah, there's actually a long history of draining turloughs, either completely or partially. Anywhere that flooding could be solved easily and cheaply, it already has been. So we're left with the really difficult places to solve, such as Cool.
And I don't think nowadays you'd be allowed to just drain it and drive a big river through it. Those rules have changed.
No, many turloughs are special areas of conservation due to their ecology. If you were to drain it, you don't want to interfere with that. You maybe just take the top level of flooding off. But when you do that, you also need to be careful that where you send that water is capable of accepting the water, that you don't make flooding worse downstream.
In 2015, a series of storms wreaked havoc across the western seaboard, resulting in Ireland's worst groundwater flooding on record in 2016. Despite centuries of knowledge, this unprecedented event highlighted the lack of scientific data on groundwater flooding. So the Geological Survey of Ireland decided to do something about that.
So what we needed to do was to start collecting the data in a systematic way, to put out as many monitoring stations for turloughs as we could across the country. Each turlough seems to have its own relationship with rainfall. A single model doesn't work on all turloughs, so you need to look at them each individually. What rain is occurring on one turlough and how does it respond? They can be quite complex. For instance, in South Galway, where we are now, the turloughs are all interlinked. There's a conduit system underground that links them all together. They all seem very similar patterns, but slightly different because placement of swallow holes or springs at different levels, and it makes it very complicated to work out.
The Groundwater Flood Project was highly collaborative, and TED worked with researchers from Carlow IT and Trinity College Dublin to manage and interpret the data. Juan Campagna is from Carlow IT.
My main role in the project is to define the relationship between rainfall data and groundwater levels. And we do this with hydrological models for predicting the behavior of the turlough.
And hydrological modelling sounds like it's quite a complicated matter given the nature of water and how complicated and interconnected it is.
Yeah, hydrological model is a simplification of the real world. And in our case, we use a mathematical model. And it basically relates between cause and effect. And the cause is the rain, and the effect is changes on the water level or on the floodings.
How do you monitor the turloughs?
In one way, we use the sensors. It measures the column of water, so how much water is above it. But this method, it doesn't help that much to do all the turloughs in Ireland. So to cover them all, then we use the satellites and the satellite images, and then we compare between the two of them to validate what we get from the satellite.
When viewed from above, seasonal changes in the landscape reveal the complex interconnectivity of Ireland's vast groundwater network.
What we're looking at here is a Sentinel-2 image, which looks like aerial photography, and we can see Cool Turlock, summer 2018 during the drought, and you can see it's very low. And then we flick through it and we can see the heavy flooding that happened last winter. We then see a cloudy image, which is a real problem for us. It means we can't collect data on the day that the cloud was there. So what we turn to is Sentinel-1, which is a different type of satellite. It collects radar data. The main benefit of this satellite is that you can see through the clouds, and so you can always rely on having an image ready. So with this time series video, we can see the turloughs moving up and down over a period of 5 years. But what's really powerful is that we can pinpoint a single place and reconstruct how that turlough has been behaving over the 5 years. And so, for instance, this is an example of one of the turloughs. The grey data is data we collect on site with data loggers, and the blue data is what the satellite is interpreting the turlough to do, is going up and down over time. And we can see that the accuracy is quite good, and we're quite happy with that fit. What we do with this information is we link it with rainfall. We can go back and at 400 locations reconstruct rainfall and the turlough's behaviour, and then start predicting what the 1 in 10 year flood would be based on the rainfall, or the 1 in 100 year flood, or the 1 in 1,000 year flood. And that lets us generate our flood map. So here we can see the dark red is the 1 in 10 year flood, or the lighter red is the 1 in 100. So it's a really valuable tool for local authorities and policymakers in the OPW. It gives them more data than they've ever had before, and able to look at groundwater flood risk and in terms of planning and where development should or should not occur.
The findings from the GW Flood project were published in 2020, and they have the potential to be a game changer for developing groundwater flooding solutions. So are you hopeful that by working with people like GSI and TCD that you will be able to solve the problem?
Yeah, I think without TCD and GSI input on this, we would still be left relying on local knowledge, which is not enough to form a scientific basis for how to solve this problem. It's essential that we have that study, but now we really need to push on. So hopefully this will be the final set of reports and we can get a positive result and move on with a compelling solution.
Petrichor. It's the word you've never heard before, but have definitely smelled. On long, hot days, as the clouds roll in and the drops begin to fall, it's the poetic yet scientific scent of rain. Coming from two ancient Greek words, Petra meaning stone and ichor meaning the blood in the veins of the gods, Petrichor's smell is earthy yet ephemeral, wet but still wonderful. It starts to come about just before the rain arrives, as the humidity begins to rise and the pores in soil fill with tiny amounts of water. Though small, it is enough to flush out plant and bacteria-made oils from the soil. This is the first step in a small but beautiful sequence discovered only 5 years ago. As the raindrops hit the soil, they trap tiny air bubbles beneath the drops themselves. This creates a champagne surge, with air bubbles rushing up through the drops, bursting and releasing the oils as tiny aerosol particles. Perfect for carrying the scent on the wind to our nose. This delicate combination of light rain on dry ground provides the scene and the scent for Mother Nature's poetic perfume of Petrichor. See you next time.
Here in Ireland, we love a good chat about the weather. But amidst all the conversations about flood mitigation measures, high winds and rainfall, there's one word that's rarely mentioned in these conversations: drought. And on a day like today, I can understand why. I'm here at Bartree Reservoir in County Wicklow to interview climate scientist Conor Murphy from Maynooth University. Conor, on a day like today, where it's absolutely lashing rain, it's kind of ironic we're here to talk about drought. Is this something we really need to worry about in Ireland?
Yeah, drought is something we need to worry about. You wouldn't think it today, of course, but in Ireland we get all kinds of rainfall, from too much to too little. When we ask the question, how often do these extremes happen, we need long records. And that's really what my research is focusing on at the moment, is trying to extend our records of rainfall, of river flows, back over the last century and more. So from the drought of 2018, we all remember that well, but in the context of long records, that was a short, sharp event, if you like. If we get back into the 1970s, the 1950s, the 1920s, and even into the 1800s, 1887, a major drought. 1893, here, Vartru Reservoir again ran into problems with Dublin water supply failing. So certainly we do drought events. We haven't experienced them to the same extent in recent decades, is the difference.
I mean, that's really interesting that in the 19th century, they were talking about the same thing about water supply in the capital city. Is there a reason that we haven't kept good records on drought?
The records that are available to science to analyse and to interrogate really only start around 1940. So we've been getting the paper records, getting them digital, analysing them and looking at past droughts. So it extends that viewpoint. So really standing on the shoulders of the observers, the meteorologists from the pre-1940 period to understand drought more.
Much of our climate change research in recent years has focused on the effects of increased rainfall, but the past can provide invaluable historical accounts of how Irish communities coped during periods of too little rain. Arlene Crampsey is an historical geographer who is bringing the human element to drought research.
The main idea behind this project was to figure out how drought periods would affect humans, so we can build up a picture of what drought experiences were like in the past using instrumental records. We can see the graphs and we can look at that, but it doesn't mean much to people on the ground. And one of the big things to do with informing the public about climate change and the impact of climate change is how is it going to affect you at a personal level? How is it going to affect you, your family, your communities? It's about bringing those human experiences to these kind of climate events.
Could we take a look?
Absolutely, yeah.
Lovely.
The project's a collaborative project, and my colleague Conor Murphy has established that the most significant drought period in the past was between 1765 and 1768. It was a 3-year drought period. But in looking at that, what we realised is that drought periods that are scientifically defined aren't necessarily the ones that have long-term human impacts. So we've been using a mixture of newspaper records, folklore material and oral histories to try and understand how people experience those droughts. And what we're discovering is that average values of rainfall don't actually have an impact on people. It's how long a period they go without rainfall that's important for either water supply or crop growth. In the past, people had spring wells, they had their own water supplies, they knew where local, maybe unused or untapped resources were, but we're now reliant on a main system. And if that means water supply can't cope with the demands of the population, then that has a really significant knock-on impact on all sectors, industry as well as just family life and day-to-day life across Ireland.
Now that you're talking, I remember myself, neighbours bringing me around to local wells and springs, but that information gets lost. We'd have to really ask the old people around the place now where those were.
We're kind of losing that generational memory of where these springs and streams are, and that obviously leads to better resilience if we can still retain that memory.
The Drought Memories Project will record new oral histories to safely archive this generational knowledge, adding to the treasure trove of existing historical accounts and manuscripts in archives around the country.
This one here is talking about the year 1826 when there came a terrible drought for 10 months. All the rivers and wells dried up. That year my grandfather saw the water of the Boyne flow through a bucket for nearly 2 months at the town of Navan. The farmers had to pull their oats because it was not long enough in the stock to cut, and their cattle died and people died too from the same cause. Oh, wow. And we never really think about drought having that significant an impact.
These long rainfall records that we're developing are of use for many people, whether it's contributing back to Med Éireann as part of the National Archive for extending those records, whether it's to Irish Water in terms of using past droughts to stress test water plans and drought plans, whether it's to local authorities or individual farmers for looking at how extremes have happened in the past in their neck of the woods. Learning from the past, whether it's the recent past or the more historical past, is really important for learning how people respond to extremes, building that bank of knowledge so we can build capacity and resilience to deal with future extremes.
Whether it's too much or too little, our groundwater resources need to be better understood and managed in the face of a changing climate that will continue to see events of flooding and drought. Geologist Katie Ted is investigating more resilient groundwater resources for Ireland.
Drought potentially has a huge impact on all of our lives. So for example, in the 2018 summer drought, almost 1 million people's water supply was in drought status. So if that dry weather had continued, we would have all seen severe impacts on our day-to-day lives. So we're looking at the impact of drought on public water supply. Specifically, we're looking at where groundwater might supply either a new sustainable source of drinking water or where it might back up public water supplies in times of drought.
We're here in the beautiful Boyne Valley, and behind us we can see the River Boyne, but there's actually a huge body of water we can see, isn't that right?
That's right. If you were to take a cross-section here, you can imagine rain falling on the two sides of the catchment and running into the water. But what's happening underneath the soil and the subsoil is there's aquifers, which are cracked rocks which hold water. And so in times of low rainfall in the summertime, lots of the river flow would be made up of groundwater. So this supports the surface water and the ecology in that way. And so in our case, a good aquifer is one that has lots of cracks. Those cracks are interconnected, so you can have a good supply of groundwater. We're measuring the groundwater levels here. There's a device in the borehole called a logger that's measuring the groundwater levels the whole time, and then that data is transmitted to the Geological Survey, so we can see what the groundwater levels are doing and how the borehole is responding to rainfall in real time. This is the hydrograph from one borehole, but we compare all of the hydrographs from the various monitoring boreholes across the country. So the Environmental Protection Agency have a network of monitoring boreholes that allow you to look at what the groundwater levels are doing. And we can use that then to identify areas with good groundwater resources, which we could recommend as an area for a backup supply for surface water supplies if that was needed.
So the challenges that are presented by groundwater here in River Boyne when it comes to drought are almost the opposite of what we see in the west with turloughs.
Yes, we're looking at both ends of the scale. The climate change predictions show that we're going to have more extreme events, both more rainfall, which we'd see as groundwater flooding in the turloughs, and also hotter, drier summers, which will manifest itself in drought situations. Drought happens in the summertime, and that's when the demand for water is the highest because, we're watering our gardens, we're playing outside in paddling pools, so we'll have to consider those sort of things into the future as drought becomes more prevalent.
That's our 10 things to know about flooding and drought. Next week, we investigate hydrogen. Could it drive the next evolution in green energy?